Inge, disculpe.
I will complete
Sí,
each task on all devices first before
El subtitulado
moving on to the
no lo pueden
next
poner en
task.
español.
I'm going to use
no,
the
no sé, no
fast
creo.
forward
No hay la
button
opción
right
en
away
la-
to get the links up,
Bueno,
and we can get going. All right, the first task is configure host names according to the diagram and the banner on switch 1 with your name. So switch 1,
Super.
enable configure terminal, and then host name, I'm going to call them S1, 2, and 3. And then to configure the banner, I'm going to use the command banner, message of the day, special character, cyber quince, and then that same special character at the end. Switch to enable configure terminal, host name S2, on to switch 3, enable configure terminal, host name S3. Next task is to configure access interfaces and VLANs. So on switch 1, we will join Fast Ethernet 0/1 to VLAN 5 and Fast Ethernet 0/2 to VLAN 7. But prior to that, we need to change their default mode from dynamic auto to access. I will explain this in a bit more detail when we get to trunk interfaces, but for now, just bear with me. Let's get into interface Fast Ethernet, and I'm going to start using the tab key now. 0/1, switch port, mode access, switch port, access VLAN 5. I'm getting this message because VLAN 5 does not exist on the switch. In order to avoid getting this message, although it doesn't mean anything is wrong, this is perfectly legitimate, I will create VLAN 7 prior to configuring it on Fast Ethernet 0/2. And the way to do that is simply type in VLAN 7, and then we are thrown into this VLAN configuration mode. I'm going to exit out of there, and I'm going to get into interface Fast Ethernet 0/2, switch port mode access, switch port access VLAN 7. Moving on to switch 2, interface Fast Ethernet 0/1, switch port mode access, switch port access VLAN 5. And now I'm going to start using the short forms of commands instead of using the tab key. You can continue to use the tab key or type the entire command. It's your choice. So I'm going to just type in interface F 0/1, switch port mode access, switch port access VLAN 5, or that's actually VLAN 7. So Fast Ethernet 0/1 is connected to a PC that should belong to VLAN 7. And interface F0/2 should belong, so switch port mode access, switch port access VLAN 5. Now, you don't actually even need to configure these access interfaces as static access. That's because these switches, so all of the interfaces on these switches are by default set to dynamic auto mode. In this mode, if on the other side of that interface, so if that device that you connect to that interface doesn't actively try to change that link into a trunk link, it's always going to be an access link. You can see that in this PDF file that I've provided. So there are several modes. There's dynamic auto, there's dynamic desirable, there's static trunk, so to say, and then there's switch port no negotiate. We can talk about this one, I believe, later when we talk about DTP and VTP, but for now, just ignore this one. The interesting mode is this dynamic desirable. That is the mode that makes the interface actively attempt to convert the link to a trunk link. So what does this mean? If we look at this link, for example, if on one side we don't change the configuration, it's going to stay dynamic auto. In order to see those modes, we will go to Show Interfaces Switch Ports, and we will be able to see all of these modes for all of the interfaces on switch 1. Fast Ethernet 0/1, we have manually configured it to be access, so it calls it static access. And then if we go to Gigabit Ethernet 0/1, we want that to be trunk, but right now it's dynamic auto. Its operational mode is static access. So administrative mode is either by default dynamic auto or statically configured access or trunk. And then operational mode is going to be the mode of the link that depends on the other side as well. So depending on what is configured here on the neighboring interface, you're going to get either access or trunk. So let's configure Gigabit Ethernet 0/1 to trunk, and then let's see what happens. I'm going to go to Configure Terminal, Interface G0/1, and I'm going to say Switch Port Mode Trunk. I'm going to go to Fast Forward, and then I'm going to issue that show command again. Only to do that from the config mode, I need to use do show interfaces switch port. When you use the do command, you won't be able to use the tab key. Just keep that in mind. Okay, let's go to Gigabit Ethernet. Here it is. Administrative mode, trunk. Operational mode, trunk. Now let's look at, by the way, if you haven't figured it out so far, you can get out of these printouts by pressing either the Q key on your keyboard or the escape key. So on Gigabit Ethernet 0/1, we have administrative mode trunk, operational mode trunk. If we go to switch 2 and issue the same command, do show interfaces switch port. Whoops. And then go to Gigabit Ethernet 0/1. Administrative mode is still dynamic auto because we haven't changed that ourselves. So that's the default mode. But operational mode is trunk because, as we could see in this PDF, if you have dynamic auto on one side and trunk on the other side, the operational mode of that link will be trunk. Let's configure switch 2. So on switch 2, we have 2 Gigabit Ethernet interfaces that should go to trunk. So I'm going to use the range command. The range command is used to configure several interfaces at the same time, and they can only be consecutive interfaces. So I'm going to say interface range Gigabit Ethernet 0/1 to 2. And I'm going to say switch port mode trunk. Then let's go to switch 3 and say interface Gigabit Ethernet 0/2 switch port mode trunk. Let's use fast forward to get the interfaces up. And that's it for the third task. Fourth task is to configure IP addresses on PCs. To do that in Packet Tracer, open the PC, go to Desktop tab. There is another way to do this, but I like this way better. Go to IP configuration and type in the address. Now, since we don't have any routers, any gateways, or servers in this network, I will just start from 1. So it's going to be 192.168.1.1, and I'm going to copy this first part because it will be the same for all PCs. Subnet mask is the default class C mask, so I'm just going to leave that like that. PC2 2, PC3.3, now that that's done, we can try ping. Let's ping PC1 to PC3. That's successful. Then we can go from PC1 to PC5. That's a bit further away, and that's successful as well. But now if we try to ping PC4 from PC2, that is going to fail. To send the ping again, the easiest way is to just double click on this evil eye or egg or whatever the hell it is. In order to see why that ping is failing, we will use the simulation mode. To enter the simulation mode, click here. And I'm going to go forward. And we will see this packet going from PC2 to switch 1, and then to switch 2, and then that's where it gets discarded. To see the details, I'm going to click on the packet. And in order to see what's the exact problem here, I'm going to go to the last layer possible and just read why it got ditched. So the reason is switch does not have the VLAN indicated on the IEEE 802.1q frame tag. It drops the frame. As I've mentioned in the presentation, in order for a switch to be able to process a packet, it has to already know the VLAN that that packet came from. So that VLAN needs to exist on that switch before the packet gets to the switch. Here's the deal. When we configured those access interfaces, each time we would join an interface to a VLAN, that VLAN would automatically get created on that switch. Now, switch 1 and switch 3 have both VLANs on them. They have both VLAN 5 and VLAN 7, but switch 2 only has VLAN 5. So if we try to send a VLAN 7 packet through that switch, it's not going to recognize that VLAN because it's not configured on the switch. The solution is actually quite simple. I'm going to go back to real time, open switch 2, and just say VLAN 7. Now let's try the ping again. Okay, I'm going to say fast forward. And now it's successful. Now let's look at the simulation. This time we don't see the ARP packet because the ARP tables already got updated on the switches. So now I can only see the ICMP. And I will actually use this example to explain into more detail the whole VLAN story. So when a packet is generated for the first time on the PC doesn't really know that it belongs to a VLAN. It will create a regular ICMP packet and send it off down the link. The switch will receive the packet and look at the interface where it came from. That interface belongs to VLAN 7. So the switch will add a tag onto that packet, and the tag will say VLAN 7. So this packet belongs to VLAN 7, and it can only be sent to other VLAN 7 or trunk interfaces. The switch then looks at its interfaces, and it will see that there is one interface that belongs to a different VLAN, so that packet can't go there. And then there is this trunk interface, which can carry any VLAN. The switch will send that packet down the trunk link. The same logic applies on switch 2. There is this VLAN 5 interface and the trunk interface, so it's obvious that this packet should go to the trunk interface. And then on switch 3, there are two interfaces, a VLAN 5 interface and a VLAN 7 interface. Obviously, this packet can only go to a VLAN 7 interface. Now, what happens to the tag? Once a packet is, first of all, received on an access interface, it is tagged. But once the receiving switch, so the last switch on the path, receives that packet and it processes it, it sees that it belongs to VLAN 7. Once the switch decides where to send the packet, if it is sending it to an access interface, it will remove the tag. So packets are only tagged while they are traveling a trunk interface or while they're being processed by a switch. The PCs don't receive tagged packets. This can happen due to misconfigurations. For example, if you configured this interface as trunk, the switch would not remove the tag, but the PC would not be able to read that packet. And the reason is because to tag packets, these switches use a .1q protocol, and the PC doesn't really know what that is. So it won't be able to read the packet, it will simply discard it. You can even look at the headers, although the packet tracer doesn't really show the .1q tag. But you can see here that we have a regular Ethernet to header in the packet. Because we are at the PC right now, there is no tag on that packet. And then if we move forward and the PC starts to send back the packet, when we look at the packet at the switch, inbound PDU details, so this is the packet that was received on this interface, still only Ethernet 2 header, and then on the outbound interface, it will have the Ethernet 802.1q header. You have your answer at the end of this document, and of course the command we used to resolve this issue. That would be it for this lesson. See you in the next one. We learned how to logically operate local area networks using VLANs. In this lesson, we'll discover a way to enable those VLANs to communicate through a router. Router on a stick is a specific router configuration whose task is to connect different VLANs. The router is on a stick because there is often several separate networks connected to a single router interface. This is achieved by creating several virtual interfaces on top of a single physical interface. Each virtual interface is a gateway for its VLAN. In this picture here, which is a topology we'll use in our exercise, we have two VLANs. 100 and 200, and only one router interface. That one interface, Fast Ethernet 0/1, the physical interface, will only be switched on, meaning there will be no other configuration other than no shutdown. Then we'll create two sub-interfaces, Fast Ethernet 0/1 dot 100 and Fast Ethernet 0/1 dot 200. The first one, Fast Ethernet 0/1 dot 100, will serve as a gateway for VLAN 100, and the second one, Fast Ethernet 0/1 dot 200, will serve as a gateway for VLAN 200. One more thing you should know before we get into the exercise is what's .1Q. .1Q is short for IEEE 802.1Q protocol, which is used for marking packets with VLAN tags. As I've briefly explained in the previous lesson, packets are tagged by switches before they are sent through a trunk link. Once the packet needs to be sent to an access link, the tag is removed. There are actually two protocols that can be used for tagging. .1Q is the EEE standard, but Cisco has its own. It's called ISL. ISL stands for Interswitch Link, and it tags a packet by adding a 26-byte header plus a 4-byte trail to a frame being sent over a trunk link. And compared to .1Q, that is a lot. Anyway, we'll be using .1Q, but you should be aware that alternatives exist. Let's go to our exercise. This time we don't have a prepared packet tracer file, so we're going to create it ourselves. That is why the first goal in our exercise is to recreate the diagram below. So let's do that. I'm going to add the 2811 router and then the 2960 switches. A little bit of OCD here. Let's rename them to S1, S2, S3, S4, and the router is going to be R1. We're going to connect the switches with a copper crossover cable. S1 and S2 are going to be connected through gigabit Ethernet 0/1 on both switches. S3 and S4 as well. And then S1 and S3 through gig Ethernet 0/2. And the same goes for S2 and S4. And then we're going to connect S2 with the router using a copper straight-through cable. And we're going to connect that to Fast Ethernet 0/1 on both devices. Let's add labels. I'm only doing this to help with configuration. You don't actually have to do that. Adding the PCs. For the PCs, we will also use the straight through cable, and we will connect the PCs to Fast Ethernet 1. So A is going to go to Fast Ethernet 1, but then B is going to go to Fast Ethernet 0/9. And we'll do that because in reality, a switch will usually have around like 12 or 24 or 48 ports. And if you have VLANs in your network, you're not really going to configure a switch all over again just because you add a new host. Rather, you will take some portion of the ports and add them in advance to a certain VLAN so that when you need to add a new host to your network, you can just plug that computer into a pre-configured port. So in this exercise, I'm going to configure the first 8 ports to belong to, in this case, on S1, to belong to VLAN 200, and then the other 8 ports to belong to VLAN 100. Let's add the labels there as well. I'm going to say Fast Ethernet, and I'm just going to say /1 because we know it's 0 slash something. If you want to use the colors, I'll show you how to do that as well. I'm going to save the empty diagram just to be able to go back to that. Okay, let's get going then. By the way, if you're wondering why there is a difference between these two, that's because this screenshot is from an older version of Packet Tracer. So no worries, we're using a newer version, so that's why there are some differences. All right, our first task is to configure host names on all devices according to the diagram and to configure a banner on the router with our names. We already know how to do that. Let's start from switch 1. When we get to the router, it's going to ask us if we want to enter this initial configuration dialog. It's actually something like a wizard. You can do that, just add another router into your working area and try that with that separate router. It's like a wizard. It makes you configure the host name and IP address, etc., etc. We don't really need to do that, and I don't think we will be doing that during this course ever. So if you would like to know what that looks like, just play around with it. It's not real equipment, so you can't really mess anything up. So we're going to say no here, and we're going to go into the configuration mode, host name R1, or yeah, banner, message of the day, cyber quins or whatever, just cyber, and that's it. Second task, configure access interfaces in VLANs. 8 interfaces per VLAN according to the diagram, of course.
Bien, perdón, me han retenido más del tiempo debido. Estamos viendo en este momento cómo se hace la implementación de VLANs a través del router. Router on a stick. Más o menos quiere decir router en un palo. Más o menos está así, ¿no? Como ustedes ven en la imagen. Es el router en el costadito. Bueno, aquí lo primero que hacemos es, bueno, está poniendo los nombres. Host name according to the diagram and a banner or R1 with your name. Bueno, aquí le cambiamos el nombre a todos los dispositivos, así como está en el diagrama, ¿no? En el PPT, en el PDF, perdón. Luego dice el punto 2, acceder a las interfaces y las VLANs, 8 interfaces por VLANs. Entonces, lo que empieza aquí a hacer es, bueno,
first, and we're going to use the range command. So interface, range, fast.
Aquí está. Pone la faja Ethernet de la 0, 1 hasta la 8. Mire, pone interface range. Esta es una forma de ingresar a un rango de interfaces. Esto no lo pueden hacer en configuración global, perdón, en configuración gráfica. Fíjense, está interface range, faja Ethernet 0, 1, guión medio al 8. Entonces, estos 8 puertos se van a configurar con lo mismo. Miren, dice, el switch port mode, el mode es access y switch port access VLAN a la VLAN que va a ser respectivamente, en este caso la 200. Es en el switch 1. Por eso está ese 1 ahí. ¿Se está viendo? ¿Me confirman? ¿Ya?
Sí.
Bueno,
¿Cuándo está creando el VLAN 200?
No, está. Ya la VLAN ha sido creada, ¿no?
Está
creada. ¿Dónde? En el router. En el router ya ha sido creada. ¿Han visto cómo se ha creado en el router o no?
Sí.
A ver, ¿dónde está?
No, aquí recién creo que está haciendo los VLANs en esa parte.
Ya, sí,
en
recién
el router,
está haciendo.
solo dice que hay que poner no y postname nada más.
Ya, ahorita como ustedes dicen, recién ha creado router, banner. Ya está el switch 1, el switch 1, la stem interface range, VLAN 200, está asignando lo que hemos dicho aquí a la 9, a la 16, a la VLAN 100. Fíjense, VLAN access, VLAN 100. Dice, access VLAN do not exist. Fíjense lo que está diciendo ahí, cito en esta parecita. ¿Ven mi cursor?
Sí.
Access VLAN does not exist. Creating VLAN, creando la VLAN, está creando la VLAN, están creándola recién. Sí, tienen razón. Ahora ya se han creado las VLANs y ahora lo pueden, bueno, lo mismo van a hacer en todos los switches, ¿no? Van a van a poner el range F1 a 8 y la van a poner en la VLAN 100, la otra en la VLAN 200. En el switch 4 lo mismo, fíjense, interface VLAN range, 1.8, switch mode, access, vean que SW, ya me estamos abreviando mucho aquí las palabras, se puede escribir así, ACC VLAN 200 directamente, ¿no? ¿Qué dice aquí? Access VLAN does not exist, creating VLAN 200, está creando la VLAN porque no hay ninguna de los, ¿no? Ahora es la cuestión. Ya saben ustedes que tienen que poner así. Ahora, no me dejen. Aquí dice, me iban a dejar encerrado. Pero ya estamos configurando, miren, 2 subinterfaces físicas para cada una de las VLANs. ¿Cómo se hace eso? Se configura una subinterfaz aquí. Subinterfaz quiere decir que es una interfaz lógica dentro de una propia interfaz. Como aquí hay un solo cable que se conecta con el switch, este faz Ethernet 01 va a tener 01.1 y 01.2 o 01.5. Fíjense aquí, vamos a configurar esa subinterfaz porque la necesitamos. Está en el switch 1, que es el switch, claro. Esos son los troncales que le llamamos, que no tienen con los equipos, sino tienen entre los switches. Fíjense ustedes, interface range, switch mode, trunk. Le está poniendo al 1 y al 2, porque en el 1 y el 2 están conectados con otros switches. ¿Se fijan? Y esos son los Giga Ethernet 0102. Giga Ethernet 0102 son troncales. Entonces, ahí está haciendo eso. Está configurando los troncales, ¿no? En el caso de, bueno, eso se hace para todos los switches, porque todos están así. Ven ustedes, al nivel pone mode trunk, por el troncal. ¿Qué está haciendo? Se están activando, ya se ponen en color verde. Fíjense, están verde ya. Están mejorando, está cambiando. Vamos a ir más aquícito. El switch 2 también. Ahí tienen las 2 VLAN. Miren, show VLAN le pone aquí show VLAN brief. Hola, ¿vienes por la oficina, por favor? Chacha. Don't show VLAN brief. Y está el número de las VLAN, ¿no? Ahí está la VLAN del 4 también. Ahí está configurando las VLANs. Ha cambiado el estatus de la VLAN del switch 4. Y ahora nos falta ese enlace que es faz Ethernet 01 con el enlace del... Le tenemos que poner no shutdown porque tenemos que encenderlo en la configuración del router. Faz Ethernet 01 config no shutdown. Encendemos y recién se va a poner en verde. Fíjense, aquí en esta partecita de este lado está Internet faz Ethernet 01.100 y le ponemos la encapsulación .1Q 100 y le ponemos una IP. Ahí le damos una IP, la 11, para la subinterfaz. Miren que está, cuando le ponemos .100, aquí abajito, ya se fijan, ya pone subif, no pone if. Subif, lo está poniendo como subinterfaz, porque le hemos puesto el .100. Encapsulation .1Q es el modo de encapsulación que vamos a utilizar para el protocolo de VLAN. Y aquí ahora te ponemos la dirección de IP porque sí o sí le tenemos que asignar una IP para evitar la redundancia, los ciclos, ¿no? El loop. Interface 01, el faz Ethernet 0100, su interfaz .1Q 200, porque es para la VLAN 200. Aquí le ponemos el número de la VLAN y le ponemos IP address. Este esta es la puerta de enlace de la red de la VLAN 200. Y esta es la puerta de enlace 11 de la VLAN 100. El número que nosotros le demos a la subinterfaz, el número de dirección IP que le demos a la subinterfaz, a donde estamos haciendo el encapsulamiento, va a ser la puerta de enlace. Así, cuando nosotros configuremos equipos, cuando pongamos puerta de enlace, para que los equipos salgan más allá de este router a otra red, y para que se comuniquen entre ellos, tienen que tener puerta de enlace. ¿Ya? Entonces, esto es lo importante del router and stick. Y esto es lo importante. Pues yo voy a grabar un videito con todas las consideraciones de esto, haciendo el ejercicio en PTK Clean, que es vamos a dejar de compartir un cachito. Vamos a presentar toda la pantalla, como no necesito ahora que... Y aquí también hay pantalla, ¿no ve? Switching Ambulance, recursos del tema. Router and Stick, 2. Y aquí dice, miren, Clean. Este ejercicio lo abren en su Packet Tracer y siguiendo estas otras que está aquí, que dice Router and Stick 2, Router and Stick Exercise, siguen todas las configuraciones. Y pueden cortar y pegar, pero yo les recomiendo que escriban. ¿Ve? Aquí está. Les recomiendo que escriban porque es mucho mejor, ¿no? Entonces, yo lo voy a hacer. Se puede copiar y pegar. Tomen en cuenta que en este lugar, la CLI es como cuando están trabajando con ¿cómo se llama? Con Linux, ¿no? Ahí tienen para poner paste, vean ustedes. Ahí está. Eso es para que lo tengan más rápido. Obviamente, este ejercicio también lo vamos a presentar como parte de la tarea, pero ni bien yo le ponga el ejercicio, lo van a ver el video y la primera clase de la próxima clase ya lo van a subir, la primera hora, ¿ya? La primera hora del día jueves. El día jueves, gracias a Dios, hay clases, no tenemos ni una actividad, así que podemos disponer de ese día tranquilamente, porque así tenemos también mucho más tiempo. Y bueno, y para el día jueves también vamos a preparar ya todo el tema. Yo se lo voy a grabar entonces y hasta donde llegue. Si es que llego hasta más abajo, también, ¿no? Si llego hasta más abajo. ¿Qué dice Cerezo? Buenos días, Inge. Buen día, Inge. Porfa, Inge, dice. ¿Qué dice Cerezo? ¿Hablé? Del video, ya. Estaría muy bien. Muy bien, no, seguro que yo lo hago. De esto creo que tengo también de Router and Stick ya algo hecho en mi canal, así que les voy a compartir. Es un ejercicio, es el mismo ejercicio. Sí, creo que ya está hecho.
Grabe la clase.
¿Ah?
Grabe la clase,
No,
todos los cursos y lo comparten en YouTube.
Ah, bueno.
Mejor, Inge.
Le cuento que no deja grabar, ¿no?
No, pues, cuando ves.
¿Cómo dice?
Cuando ves, cuando deja.
No deja grabar. No deja grabar porque son cursos de Udemy y no dejan que lo grabes, ¿no? Ni que los, ¿cómo se llama? Ni que los descargues, ¿no? Si vos agarras, por ejemplo, el video downloader que yo tengo por acá. Aquí, a ver, el video downloader. No está, ¿no? Mostrar lista de videos. No me sale. No está. Estas extensiones no dejan, no dejan. Pero esto está. Esto, a ver, para que los que quieran ir viendo, configuración router and stick, esto está en internet, en todos lados, ¿no? Configurar VLANs router on a stick. En español más le vamos a poner. Por ahí alguien ya lo ha replicado, ¿no? Ahí está, miren, hay una configuración aquí de VLAN, inter-VLAN routing on a stick parte 1 y parte 2 igual. Este es muy bueno, sí, yo me acuerdo que este lo veíamos mucho más antes, Jorge Armijo. A ver. ¿No están viendo en mi pantalla?
No.
Ya, se los voy a pasar entonces para que ustedes lo puedan. Es la misma configuración, ya, interVLAN. Ya abajo. Sí, pues tengo clases, ¿no? Bueno, chicos, que tengan muy buen día. Nos vemos el día de mañana. De pasado mañana.
Bueno, hasta luego, permiso.
Hasta luego.
Chao.
Hasta luego, Inge.
Hasta luego, queridos. Hasta luego.
Hasta luego, Inge.